All right, we're going to do a quick overview of the LFP 100 Pro portable solar generator system. This system right here is using the latest and greatest battery, solar, and battery monitoring technology that's currently on the market. So we had an LFP 100 that we built first. This is the upgraded version of that. This has a pure sine wave inverter, meaning that it will supply pure sine wave power. That means the waveform is the same or cleaner than what the power company provides you with. This is important if you're running electric motors or sensitive medical equipment. So anything that you normally plug in a wall will run just as well or better than it does at home with this system. It's rated for 900 watts continuous and a surge of 2,000 watts, and it says it's rated for 1,000 watts for 5 minutes. That's kind of an understatement based on our testing. We've been able to get 1,300 watts for basically draining the battery from full to halfway full. And what will happen is it'll just start to get too warm. It'll overheat, and you'll have to basically drop your load down. So you can power higher loads for 20 minutes, then it's rated capacity. But it's rated for 900 watts continuous. It's a pretty good inverter. You got the digital display right here. You got a USB port also, so you can plug in your iPhones, iPads, USB stuff. Green LED, if there's ever a fault, this red LED will light, and then you can come and see what fault condition has occurred. Push the button on off to reset it, and you'll have power again. You have GFI protected AC outlet, same thing you see in bathroom and kitchen, so this will not electrocute or shock somebody. It'll trip the circuit if it does. If less power comes back than it's putting out, so that's a good feature. Another thing we built in is a 1100 watt multiple power point tracking kind of a solar charge controller, but it's able to handle wind and hydro input power also. This is made by a company called Midnight Solar, and this is their latest invention. The charge controller can handle 1100 watts of input power from these sources: solar, wind, or hydro. It's set up for solar input, maximum voltage input 150 volts, maximum charging current 80 amps, and the maximum wattage around 1100 watts. And then we have a nice locking 100 amp solar, wind, and hydro input connector. And we'll show you that connector in a minute, but it simply locks in place. You can't hook it up backwards, which is handy. Another thing we have, which we have included in most of our systems, is a digital battery monitor, and this battery monitor or fuel gauge tells you exactly how much power you're consuming, how much power is left in the battery. TTG is time to go. It tells you how many hours and minutes you have until the battery will be drained completely. So based on letting the system sit idle and powering the charge controller and the inverter, we have 49 hours. The battery is 36% charged. So state of charge 36%, 100% is fully charged, 0% is empty. Consumed energy, we've taken 65 amp hours out of the 100 amp hour battery, and we're currently pulling out 0.72 amps to power the charge controller and the inverter. And then it also has a historical section to where it'll give you basically the history of how the battery has been used. So that's that, simple to use. There's a graph right here that kind of tells you what these V stands for, I, consumed energy, stuff like that, so you know what these stand for while you're using it. We have a simple on-off button switch right here. So this switch right here will turn the system on and off. Battery monitor always stays on. You can see the charge controller is no longer on and the inverter has shut off. If you're going to store the system, you turn it in the off position. All the current, see there's no current being drawn from the battery because nothing's being powered. And to turn the system back on, we just simply hit the switch. It'll move up, green light will turn on. Solar charge controller will cycle on. And the inverter will need to be turned on. And now you have AC power. If you don't need the AC output, you simply turn it off. Now, on the front of the system, we have a few different output ports. So one, we have these heavy-duty battery terminals, basically. They're rated for 500 amps. The maximum current you can put in or pull out is 120 amps at 12 volts. This is a 12-volt battery. You got a symbol right here, so you know this is your positive battery terminal. You have a nice knob, stainless steel nut. So you could put ring terminals on here or jumper cables if you needed to jump start a car and tighten it down. Same thing over here for a negative battery terminal. 120 amps, 12 volts. This is just a negative connection to the battery. The built-in battery management system will turn the output to these terminals off and the cigarette lighter outlets at the bottom if there's ever a short circuit, if the battery is drained down to a 10.5 volts. So it'll shut the output to these terminals off once the battery is basically empty, to keep from over draining the battery. If there's ever a short circuit, it'll cut the output to these off also. So when you hit this on-off switch right here, when the green light's on, that means you have power to these battery terminals and these cigarette lighter sockets. Each cigarette lighter socket supplies 12 volts and is capable of supplying 15 amps, 200 watts. Each one has its own separate breaker. So you can pull 200 out of here, 200 out of here for 400 total. What we're going to show you now is we're going to lay out about 800 watts worth of solar panels, and then we're going to show you how we connect those and then show you how quickly you can recharge the system. Alright, we got 8 120 watt folding solar panel sets laid out. They're wired up and we're going to connect it. Let's just go over the panels real quick. These are 120 watt folding panels. We like them because they're affordable, they have great performance, and they're easy to tilt for maximum performance. So tilting the solar panels toward direct sunlight can double your output versus just laying them flat on the ground when the sun's not directly overhead. So with these, we got built-in aluminum tilting arms. They lay flat inside the panel when they're folded up, but for now we just lean them out so the panel is tilted towards direct sunlight. That'll get us maximum output. They weigh 30 pounds each, so they're not the lightest things in the world. They're pretty durable. We ship them across the US, never broke one yet. And for the money, we include them with the kits because a lot of people just want a system for home, and this is perfect for that. So if you got something you're just going to store in your garage until you need it, these are easy to pull out, set up, and connect, and you're good to go. We have easy Anderson power pole connectors. So each panel has its own Anderson power pole connector, and then our custom wiring system that comes with it is set up just for what you buy. You just snap them in place, lean them towards direct sunlight, and you're good to go. Now we got a 50-foot cable here, and here's the other end of our, it's called a Deltran 100 amp locking connector. It's got this twist lock right here. So this is where we plug in our solar panel input right here. You can see our charge controller has 0 input. Left hand side incoming voltage is 5 volts, that's a resting, 0 watts. Battery's at 13.1 volts and 0 current coming in. So what we're going to do is connect these 800 plus watts of solar panels and see how quick we can recharge the system. Hear it lock in place. Now we can watch the solar input here. So if we look, it has found the maximum power point of this solar array to be 62 volts. They're wired in strings of 2, So 220 watt panels are wired in series. We have 4 pairs doing that. It's an 88 volt panel system. This allows us to use thinner wire and to run at longer distances. So we got 50 feet from the system to the panels with this setup. It's possible to do more if needed. But if we look at our wattage here, we have 730 watts. This charge controller is one of the most efficient on the market, so it's going to harvest more power over the course of the day than anything else you're going to buy or could think about buying. If we look at our battery voltage, we're at 13.6 volts. We're bringing in 53.7 amps. That's 700 watts. If we hit our status button right here, it'll take us through different basically displays. It'll display different data. So this, we still have our solar panel maximum power point voltage, still got our wattage, but now we have, instead of kilowatt hours, which is every 1,000 watts is what the last one was going to show, we have amp hours, which is AHR. The system, the battery has 100 amp hour capacity. We've brought in 1 amp hour so far. We're in bulk charging mode. Multiple power point tracking is enabled. And click this again, and we have incoming voltage. We're bringing in 12 amps. The multiple power point charge controller is converting 61 volts at 12 amps down to 13.6 volts, which is what we need to charge our battery. And we're converting 12 amps to 54 amps. This is what allows us to use thinner cable because we're running less current at higher voltage, kind of like your house does. They run power from the power company at extremely high voltage so they can use thinner wires, and then they down convert it when it gets to your house. So the open circuit voltage of the array is 79 volts. Maximum power point 61.5. This is always tracked and it's always adjusted to get you the maximum power. Right here is a graph. So this will actually graph over the course of the day, every 3 minutes, what the incoming power is. And then over the course of the day, what you'll have is a log and a graph that'll show you exactly how much power has been brought in, like every 3 minutes. So if it's up and down, it'll show you up and down, or it'll be a curve from the beginning of the day to the middle to the end. And you hit the up arrow to go through. Voltage in 5.5 is because it was resting. So as time progresses, it'll keep logging this information. You'll have a graph to look at. And it logs this for I think 6 months. 6 months of data will be stored. Battery voltage. This also logs battery voltage. So as the battery voltage goes up and down, it'll show you a graph of that. And then kilowatt hours. This is every 1,000 watt hours that are harvested. It'll show you that in a graph also. So to get out of that, you just hit the status button. This is called a moon graph, and it's basically it's just a line that shows you the battery voltage and then how high above the solar array voltage is. Not very useful, but it's just a feature they built in. And then here's our main display. So we're bringing in 743 watts. It's a little bigger than an 800 watt array. You got to understand that solar panels, when heated up, the industry average is they provide about 77% of their rated power. I usually see better than that out of these, but there's a lot of conditions that will affect the amount of power you're actually getting out of the panel. There's a little bit of shading at the bottom where the grass is, which will affect it a little bit. We're still getting pretty good harvest. So if we look at our battery monitor right down here, state of charge is 39.4%. You can see how that's ticking up at a pretty decent rate since we're charging at 54 amps. That basically would give us a little less than 2 hour recharge time from an empty battery to full. And that's the main advantage of this LFP Pro system, is that you have such a more powerful charge controller. You can recharge this battery with a 1100 watt solar array. You could actually recharge this battery in 1.5 hours or a little bit less than that. So this is a system at home, you have a couple hours where you're in an area of the country to where the sun isn't perfect all the time, and you have a short period of time to harvest the power that you need. this system with the higher input capacity will allow you to harvest more power quicker versus our older system that was limited to 200 watts, which took 7 hours. 2, 4, 6, 8, 10, 12. Yeah, it took about 7 hours for a full recharge with the 200 watt solar panel, but you could never go quicker than that with the way it was set up. So we'll look at this. You see our state of charge is just ticking up at a quick rate. Consumed energy will count down because we're putting power back into it. Plus number means we're putting in, battery's actually receiving 52.4 amps. Charge controller's putting out 54.1. Some of that's going to supply the power for the charge controller, some of it's going to supply the power for the inverter. If you're powering stuff at the same time, basically the power that you're bringing in, let's say you're powering something that's 200 watts, 200 watts of the solar harvest will go to the device you're powering. The rest of it will be stored in the battery. When the battery is fully charged, the excess power, it'll basically idle down the power it's bringing in once the system is fully recharged, to where it'll only pull in power when you need it once the system battery has a full charge on it. So this is it. I mean, you can hook up solar panels, wind turbines, or hydro electric generators, and it'll bring in power just as we're showing you with the solar charge controller. Set this up anywhere in the world, anywhere the sun shines, anywhere it's windy, anywhere you got hydropower, system operates the same. Provides you with 12 volt DC, 1,900, 1,000 watts of pure sine wave AC power, and you can use that to power whatever equipment you need to power. System stores 1.28 kilowatts of power, so the battery has a capacity of 1.2 kilowatts, and the system can be charged with the case closed. You just can't turn the inverter on because it'll overheat with the case closed, but you can close the case, leave it outside. We prefer it be covered or in a sheltered area, but when you have it like this, you can leave it outside with the case closed. All right, we're going to power up a few different regular household devices just to show you how much power that the inverter is able to actually supply versus its rating, which is 900 watts continuous, 1,000 watts for 5 minutes, 2,000 watts surge. Another thing that a lot of people like about these systems over the alternative, which is kind of cheaper but not really useful in emergency situations where it's a real emergency and there's no gasoline available, are gas generators. And a few conversations I've had with people is, you know, why are you willing to pay more for something like this? You know, over and above that, you know, gas generators don't work in emergency situations where you can't get gasoline. And one of the things is sound. These systems are virtually silent. So what you will hear is the inverter has a built-in cooling fan. So the cooling fan is turned on by temperature. So when the internal temperature reaches 122 degrees Fahrenheit, it turns on, and then it turns off once it is below that. But it'll rev up, so it doesn't just turn on at one speed. It revs up as the heat increases. And there's a fan right here in the back. Might not be real easy to see, but there's the outlet right here, and then it sucks air from the front and underneath, blows it out the back. But that's as loud as the system gets, is basically a computer fan. So let's plug in this. We already got it plugged in. Let's turn on the vacuum and see what kind of power it pulls. And then when we turn the vacuum off, if we let it run long enough, we'll be able to hear the fan running on the inverter while it cools down.
So if we look, the inverter is telling us it's alternating between battery voltage, 12.7 volts, and the amount of AC power it's supplying to the load, which is the vacuum cleaner. The vacuum's pulling 900 watts.
So I'm not sure if you could hear that, but the vacuum is consuming 900 watts of power. So you can see that the output has gone to 0, 0, 0. We'll turn this back on.
Pulling 75 amps out of the battery. You see our consumed energy is counting up. Data charge is going to go down. Time to go takes 3 minutes to give an accurate reading, but it'll tell us exactly how many hours and minutes we have until the battery will be drained based on this load. So after 3 minutes we'll have an accurate number, but right now it's definitely less than an hour.
We'll turn that off now. You can hear the inverter. All right, here we have just a regular hair blower, 1875 watts on high, which is well beyond our rating for this inverter. So if we put it on low, we're consuming 380 watts. And now we'll show you, we'll flip it on high, it's going to try to pull 1800 watts. The inverter is going to show an overload error message and start beeping. EO3, if we look at the legend here, EO3 is overload. So to fix that, we'll turn the fan off so it doesn't do it again. And we'll hit the power off button. And then back on. And now we're good to go again. So if you overload it, I mean, that's basically what'll happen. It'll just let you know, hey, you overloaded the inverter and it's trying to pull too much power. So we'll show you some more devices. Alright, so what we have here is a skill saw, and we'll just show you guys out there, you can power your power tools without much problem, and how much power this pulls. If I remember correctly, it was 400 watts, so we'll turn this on real quick and show you how much power it requires. So it pulled about 800 watts on startup and then went to like 500 watts while it was running. We'll do it again. So, yes, you can run your power tools. I got a couple more we can plug in. Okay, we got a regular shop back here. pulls about 1,000 watts, a little over 1,000 watts. So this shows you that the inverter, can handle 1,000 watts without any problems.
Almost 1,100 watts. You can hear how the fan ramps down. So it's really as loud as it gets. If it gets hot, the fan will run continuously, and that's about it. The vacuum's pulling, making more noise than this ever will. So we'll show you something else. All right, we got another device. This is basically a heat gun for removing paint, and we use it for heat shrink. Shrink and heat shrink material, and it can pull about 1,000 watts. So on low, about 500 watts. Flip it to high, and we're pulling 1,300 watts, 1,300 watts. Let's just start. This gets glowing hot red. So let's turn it at 1,300 watts of battery power into pure heat. You can hear the inverter fan start to ramp up. So I was able to run this for maybe like 20 to 30 minutes before. It was during the day, it was a hot day, but the inverter essentially gave the overheat error message, and I had shut it off. So the results are varied. The inverter's rated for 900 continuous, 1,000 for 5 minutes, but this just goes to show you it's a heavy duty piece of equipment, and it can power higher loads for short periods of time, although it's not rated to. You can hear the fan at full blast. And that's it. This is an example of how you're not really limited by 900 watts, at least for the short period.
And one other thing, it's another power tool, but it's a skill saw. So it's pulling about 250 watts, not much. And of course you can power lighting. This is a halogen light, so it's just wasting power compared to a LED light or a compact fluorescent light. We recommend our waterproof LED lights if you want something super efficient and pull a fraction of the power this thing's consuming. But it was here, so I figured I'd show you. So this is consuming 120 watts. 120 watts. We can get a light to do the same thing at about 10 to 12 watts.